Hey, what you guys just heard was the actual recording of the Apollo 11 countdown, just exactly as it occurred, okay? And I was there at the launch, so I know it happened that way. But I'm going to go into a little background on this, and I've got some pictures to show you. Okay, first, my name is Gary Thompson, and this is all about rocket science. It's actually about developing the engines that went into the Apollo Saturn program. And I'm going to show you what happened here. I got to get my little pointer so I can see what's going on here. All right. You probably got some information from Mrs. Hacker about the space program. She probably went through the general thing. We're going to talk about nothing more than the Saturn Apollo program, which occurred back in the 60s, from about 1963. John F. Kennedy actually authorized the program in 61. But I think it really got started in about 1963 when we started developing the rocket engines for it. The Mercury program came first. That was a one-man program just to make sure that we could put people into space around the Earth. And then we went to the Gemini program. You needed a crew of 2 to do more stuff. And so you couldn't do any experiments in space unless you had 2 people to do it. And then finally, we wanted to send people to the moon. That was going to take a crew of 3 people. It's the only way you could make it to the moon and back. You had to have all 3 people because there were things to do. The Apollo missions had a number of firsts. This is going to be, we've never seen the far side of the moon before this. So the object was to see what the other side of the moon looked like. This would be the first time that man has ever left Earth and gone to deep space. First time we used solar power. And when you're running a liquid fuel rocket engine, there's some difficulty in starting the engine. When you start a car, you just turn the key and it starts, right? But when you start a liquid-fueled rocket engine, there's 2,000 things that have to happen in the first 5 seconds. It's a little more complicated than starting a car. And these things have to happen in exact order and in exact timing. So it's pretty difficult. And to restart it after you shut it down takes even more expertise. So that's what we had to do. And then, of course, there was the first landing on the moon and the launch in space. So a little bit about my background. I was born in 1935. So that makes me pretty old. But fortunately, it was the right timing to get into the space program. I went to the Naval Academy. When I graduated, I went into the Air Force, and I sort of hung around the Air Force for a while, but then I got exposed to rockets and missiles, and I got really interested, so I went to work for Rocketdyne. Rocketdyne is a company in California that built rocket engines. That was their whole thing. That's all they did, is built rocket engines. And the main thing they built was liquid-fueled rocket engines. There's a lot of different rocket fuels, but the one I got really worked on was the J2 engine, 200,000 pounds of thrust. And how much do you weigh? You don't know? How much do you weigh? You don't know? How much do you weigh?
Something 100.
About 100? All right. Well, this engine puts out 200,000 pounds of thrust. That's a lot. Right. So I got involved with the testing of these engines, and it's pretty exciting. When you fire one of these things up, it shakes the ground all around. Absolutely shakes the ground. So it's powerful engines. And I took one of the first engines down to Cape Canaveral, and then we put it on the rocket down there. I'm going to talk a little bit about the Saturn 1B, which is the rocket we put it on. And I stayed down there through Apollo 11, which was the moon landing, and participated in all the Apollo Saturn launches. And then I sort of got excited about computing. Now, we were still working with punch cards back in those days, but it was very interesting stuff. So I sort of left the space program and got into computing, and I've been there ever since. I was here in St. Louis with Anheuser-Busch for 22 years, so I've been around St. Louis for quite a while. And I'm really retired, but I have a little software company that I run. I've got some cards here if anybody wants one. Get in touch with me or whatever. My email's on there. So that's my history. So these are the two vehicles that I got involved with. The one on the left is called the Saturn 1B, and it was a small rocket. It was designed to test all the capabilities, particularly of the J2 engine, which was in the second stage. The first stage had 8 Rocketdyne H1 engines. The H1 engine was a kerosene engine, basically like a Redstone engine. That's what it was. It was a really old style engine, but very tried and true, and it worked every time. So they never had any problems with it. The Saturn V, the only way we could build a Saturn V was to make sure the Saturn 1B worked. So we had to step up to the Saturn V, and I'm going to go through all that development and tell you all about it. There we go. Okay, going back to, in order to put a single person up, you need a small rocket. One engine, Redstone engine, that could put one person into orbit around the Earth. To put two people up in the Titan Gemini, 2 engines. And then when you get up to these other ones, you need a lot more engines just to put 3 people in orbit. And believe me, these people were packed into this little tiny command module up here, and they were really packed in there. So there's no room to run around like the space shuttle and all that kind of stuff where they could walk around. No way. No cockpit. They were just seated in there, and that was it. But it worked. This is the Saturn 1B as compared to the Arch, or the Saturn V, I'm sorry. So the Saturn V was over a football field in height, pretty high. But the Arch is what, 630 feet, 2 football fields, so it's almost twice as high. So you get an idea of the size of that Saturn V rocket. Saturn II was the second stage of the Saturn V. There was 3 stages: the Saturn I, Saturn II, and the Saturn S4B. Those were the 3 stages. And as I said, it takes over 2,000 events that have to happen in the first 5 seconds in order to get a rocket engine started and running properly. What you got? Okay. We had to do some tests. We actually had some failures. Here's a failure that happened at the, we used to test in the hills up above LA, the Santa Susana Mountains. That's where we did all our testing. We had some test stands up there and the blockhouse and all that good stuff. And I probably was involved in about 200 different test firings of this engine, okay? So it was really interesting to try to get this engine to run right. And in this case, the injector didn't work exactly the way we anticipated. It crashed. And it poked a hole in the side. These are the fuel tubes, actually, that were used to cool the engine. the fuel would come down into these tubes and flow all the way down to the end, and then all the way back up into the fuel pump, okay, in the injector. So that's how you kept the engine cool, because liquid hydrogen is minus 425 degrees Fahrenheit. You know how cold that is? That's really cold.
That can, like, freeze your skin.
Yeah, that's its boiling point. That's where it turns to a gas, okay? And so it's really cold. Liquid oxygen, minus 350 degrees. So it's not quite as cold, but it's really cold too. So I know when we were working out on these test stands, the humidity was just killing you. I mean, the moisture was coming off of these tanks above us. And you were just soaking wet out there. Okay, this is the first Saturn Apollo vehicle, and my boss gave me this picture. And by the way, all these pictures and everything came out of a scrapbook. So what I did was I just took pictures of the scrapbook pages. So that's what you're seeing here, okay? So it's nothing, these things are out of my own personal scrapbook, and sort of a record that I kept of what went on. First Saturn Apollo was a big success. It was unmanned. We didn't put any people on top of it because we didn't want to risk anything. But it went like clockwork. It really worked well. And there was a mock-up of the Apollo command module. And then we went to the second one, unmanned launch. This one didn't even have a command module on it. It just had a nose cone. But the idea was to launch and test the firing of the second stage. And that worked really well too. And then before we launched, we did have a little problem. The circuitry that does those 2,000 events is in a little tin box. It's on the side of the engine, and it didn't work right. It's called the ECA. And did it heat up? No, it didn't heat up too much. It just didn't work. Okay. In this case, we did have some cases of overheating, but not in this case. In fact, during the testing, we burned out several of the things that were supposed to create what we call the gas generator would try to heat up. Most of the metal that we had on the engine would withstand about 1,200 degrees. When you got up to 1,700 degrees, everything melted. So if you didn't have the right mixture of hydrogen and oxygen, too much oxidizer and everything burned up.
How big was the solid state logic that you're talking about, that ECA?
Well, the ECA was about maybe 13 inches, 14 inches, and about that big.
So how many transistors were in there?
A lot of them. Yeah, they were built on circular plates and then all wired together. But they were, it was just all transistors, that was it. And it was amazing because the thing had to be sealed, vacuum sealed, and it was really they were built as a unit. And if they didn't work, it was terrible to take them apart. So we put on a replacement, and they got it back at the factory and diagnosed the failure, and it wouldn't happen again. So we were cool with that. This was a night launch, first night launch of a Saturn vehicle. In fact, I think this was the only launch that ever was pulled off at night. It was beautiful. Really beautiful. Lit up the whole Cape. Really gorgeous. And this one had TV cameras mounted inside the fuel tank. So the problem was that when you get into orbit, into space, everything is kind of floating. You know, it just floats around, people float around. And, well, so did the fuel. So we wanted to start the engine, but in order to start the engine, you had to have the fuel all the way at the back, right over the valves that let it into the engine. If you didn't, you get air into the, or space or whatever, but you wouldn't get the right mixture, and you could burn the engine up. So what we had was little rockets on the side of the thing, they call ullage rockets, and we would trigger those, and the vehicle would lurch a little bit, and all the fuel would bang to the bottom, and then you'd start the engine. So we had a little rocket engine sequence ahead of the regular start of the main engine. And we got to watch this. When the thing came over the Cape, we had the TV cameras turned on, and we could see this inside of the tank and all this fuel floating around in there. And then when they fired all these rockets, boom, it went to the back, and you could see that it was working perfectly. It was great. So that worked perfectly, and we were able to restart the engine. Now, this was key to getting us to the moon, because if you couldn't restart this engine, you couldn't take off and go to the moon. So that was the whole deal. But we had a disaster. On the next vehicle, which was designated as Apollo 1, the crew, Grissom, White, and Chaffee, were lost. And as it turned out, some notes here. I was out at the Cape that night, and we were doing what they call a wet countdown, CDDT, or a countdown demonstration test, which we would run, load all the propellants, load the liquid oxygen, load the hydrogen, and everything was ready to go. We take it down to T-minus 20 minutes, and then we kill it. That was it. But the astronauts went in there at about T-minus 2 hours, and then somewhere around T-minus an hour or something like that, there was a fire in the capsule. And with a liquid oxygen, or a pure oxygen environment inside this capsule, everything just burned up just like that, boom. I don't know if you're familiar with pure oxygen, but it's very flammable. So that's what happened to the astronauts, and we learned at that point in time, at pretty high cost, that we had to mix oxygen, hydrogen, and or oxygen, helium, and nitrogen in a mix to supply for the crew capsule. So that's what happened after that. But it took us a year to get that all together. So finally we had a successful launch of a manned Saturn 1B. It was called Apollo 7. And my boss sent me this picture. So it was a beautiful launch. I mean, it worked perfectly. Apollo 7 astronauts were put into Earth orbit. I think they went around about 8 times, and then they descended into the ocean and landed by parachute. So this talks about the first manned launch. That's another picture. And of course we pat each other on the back with congratulations. So this was these are just things that I put in my scrapbook, okay? It was very successful. We now had all the concepts together to build a Saturn V and make it work. The liquid hydrogen fuel engine we knew could start in space so we could go to the moon. That was the big deal. So we were on the brink of success, and now we went to the Saturn V. There's a picture, another picture of that launch. And now I'm going to switch screens here. Okay. All right. Now we're on Saturn V. That's the big rocket. The launch pad was about a mile from the blockhouse. Okay, it was quite a ways away. And you can see it. This is pad 39 with the Saturn V rocket getting set to, just sitting out there, being tested, make sure it's ready to go. The countdown that we went with these things, we do a wet countdown down to T-minus 20, and we do a dry countdown, which just tested the last sequence, but didn't do anything, with nothing on board. And then we would do the real thing. So, and this is where we assembled the vehicles. It's called the Vertical Assembly Building. It's, this is the firing room off here to the left, the blockhouse. Has shutter windows. We close the shutters when it launched.
Was it that bright?
Huh?
Was it that bright?
It wasn't the brightness, it was the blast.
Oh, the blast.
Right. This was, we're talking 7.5 million pounds of thrust. 7.5 million pounds, it's huge. Right. And it threw stuff all over the place, you know. So, we could put 4 of these Saturn V's in the vertical assembly building. We, as far as I know, though, we never had more than 2 in there. Okay. Our offices were in that building. And we just go from there up to wherever we had to do whatever we had to do on the engine, depending on what it was. And during launch, we monitored all the charts so that we knew exactly what was going on with the engine before it launched, because we had to chill it down, get it down so that when you hit it with the liquid hydrogen, it wasn't immediately gassed. So we had to chill it down too. And we'd take visitors up on the roof of this thing. It's 560 feet tall. You could see the entire Cape from there. You know, it's a really beautiful sight.
It's like almost smells the art.
This is where we did all of our pre-flight engine tests. Sometimes we had to replace items on the engine. In this case, I'm going to show you some pictures of, this is the LOX liquid oxygen turbo pump. It had a turbine in it that spun with hot gases, and this kept the turbine pumped up and pressurized the liquid oxygen that went into the engine of 2,000 psi, pounds per square inch. And this was the turbine that did it. And we had to, you can see people pulling the turbine out. That's what it looks like. Also, sometimes we had to replace an entire engine because of engineering changes. Sometimes they found things that could possibly be a flaw, you know, in the design of the engine. That's okay. You guys got any questions, by the way, just shoot them at me, because I don't want to get too far ahead of you. But I'm going to show you some pictures about how we replaced the engine. This is, we used a winch, and here we're lowering the old engine out down to the platform. This is the top of the engine. You can see a lot of plumbing here. A lot of plumbing. And you had to really know everything on that engine, where it went, what it was doing. This thing in the center here is called the gimbal block. That's where it plugged up against the stage. In this case, this is the S4B stage. And this gimbal block could swivel 360 degrees. So that's how you directed the engine, where it propelled the rocket in flight. You'd move it just a little bit, and it would go off at an angle. So.
How much ability did they have to steer once they were launched?
A lot. Well, it was all steered by gyro.
Okay.
I mean, the astronauts don't steer it. They're along for the ride. when they get into the service module and the command module, they did have steering, but not during launch. No steering at all. Everything was done by gyro control because they couldn't possibly steer. They couldn't see. You know, this thing is closed up. You know, they did have a window, but you know, you can't.
Pressures and stuff, I would imagine it'd be hard to
Yeah.
do anything with any fine.
Yeah, they're going up to 25,000 miles an hour. you're just going too fast to react. Okay, but the gyros did the job. And that was how the engine was moved, was on those swivels. Here it's being winched up into the, now you'll see it being winched up here, and this ring thing around here, that's a temporary thing. We had this thing, it would fold down, and you could walk all the way around the engine to work on it. It's really neat. And I'm going to show you some pictures later on how we worked on the engines. This is kind of the plumbing. This big line in the middle here that's 3,000 pounds per square inch liquid hydrogen at minus 425 degrees. So there's a lot of hydrogen going through that line. A lot of it. Yeah.
Pipes bursts.
Well, then the whole thing's going to go down. You burst a pipe on this engine and it's totaled. Nothing can work, nothing can happen to this engine when it's running. It has to work perfectly. Absolutely perfectly. You can't have a malfunction. And if you see the bottom line here, all of the engines that we worked on, they started and ran like a top every time. So they all, and the reason they work so well is because we tested them. We'd put a throat plug, it's a plug that went into the main chamber, and seal that engine. And then we would pressurize the engine with helium. Helium was about the only gas that we could use to get in there, and we would measure at every possible point on the engine how much helium was escaping. Because if you had any leaks in there at all, it was a killer. So it was really important that we measured all the leakage throughout the engine. So this is just a picture of my business card. So, and then somehow I got recognized for something I did, and I don't even remember what it was. So, but one of the other things we had to do was NASA. You know who NASA is? Or, National Aeronautics and Space Administration. But they were the people that ran this whole space program administratively. And we did all the work, but they ran the program. And we had to demonstrate that we could get inside the engine and repair it whenever we had to. So one of the things we did was show that we could pull components off the engine, you know. And in this case, we're pulling this is the fuel turbopump, weighed about 200 pounds. And we've got a special jig for holding it in place while we winch it off of there, okay? And then this is me. I was demonstrating that we could take off the largest component on the engine, which was called the crossover duct. It took hot gases from the fuel pump and brought it over to the liquid oxygen pump. So, and here's the stand that I was talking about. It went all the way around the engine, so you can see just a corner of it there. So that was how we demonstrated our capabilities. The first launch was Apollo 4, Had no command module, but we had everything on board. We had all 3 stages. The first stage had 5 of these F1 engines, 1.5 million pounds of thrust apiece. They were kerosene fueled, and they generate 7.5 million pounds of thrust. Actually, a little bit more than that. That's a kind of an average. S2 stage was the second stage. I had 5 of the J2 engines, liquid hydrogen engines, generate 1 million pounds of thrust. And then the S4B stage was the one that took them to the moon. So, and then there was a little tiny rocket on top. I don't know whether you got to see that or not, but you'll see it in some of these later pictures here. That little tiny rocket at the top, the tip, that's an escape rocket. In case there was a problem during launch, that would pull the command module off of there and then pop the chute so that the astronauts could escape alive.
When was that implemented?
Always was there.
It was always there?
It was always there, yes. The only incident that they had was not during a launch, it was during a practice launch. So all the other missions worked perfectly, and they would jettison this. In fact, if you go through the countdown, you'll hear them call out jettisoning the escape tower. You know, so this worked great. Then we went to Apollo 8. This took us up to the moon, around the moon, and we got to see the backside of the moon. Okay, there it is. First time we got to see the backside of the moon. These were the 3 astronauts that went up there with that one, and took a lot of pictures of the surface of the moon. We were looking for landing spots where we were going to land. This is Apollo 8 now. And this is the first pictures that we got of the Earth ever from that far out in space. So we got some really great pictures from this mission. And of course we got congratulations all around because it worked perfectly. We got the astronauts back, we got all the pictures, we got everything. You know, so everything, and we got all the testing from Apollo 8. That was the first spacecraft to orbit the moon. Then there was we had another Apollo mission, but it was strictly for testing all of the components around in Earth orbit that would be used to go to the moon. In other words, the LEM and the service module. And then Apollo 10, we did the same thing, but we did it in moon orbit. And they got great pictures with this one of a landing site that they used in the Apollo 11 mission. And my son got this cover letter, commemorative stamp. We got all kinds of congratulations on that mission. That was a good mission. There was a picture of the LEM as it was deployed for looking around at. They didn't do any landing because they couldn't do it at that time. But then we have AS-506, which was the last mission that I was in. And it was perfect. That Apollo 11 mission was as perfect as it can get. There's a picture. There's the logo. Pats on the back again. Also, I was a member of the Space Pioneers at Cape Canaveral. So there's my membership card. Oh, my son went to school there in Titusville, and he turned in a paper on the Saturn V. He's about your age. And he got an A- on it. So that was pretty good. This is a kind of a map of the Space Center and Cape Kennedy as it was called then. It's now back to Cape Canaveral, which is when I went down there it was Cape Canaveral. When I left it was Cape Kennedy. Now it's back to Cape Canaveral again. It's a great place to visit. If you ever go down that way, the museum is awesome. It is awesome. And I used to go around, I gave a few demonstrations. This is another picture of me back in 1969. And you see I had a model of this is the J2 engine model, you know. So, any questions? Anything you want to know? I've got some cards up here with my email on it if you want to ask me any more questions later on.
When did they switch to like solid fuel instead of?
Well, that was with the shuttle program. They went to the solid fuel booster rockets. Yeah, and they're not so good. Well, they had a few problems with those, okay? They've had 2 bad experiences with those.
Yeah, I don't
So,
know that much about it.
the one thing about the liquid fuel rockets, you can shut them off. There's no way to shut down a solid fuel rocket.
It's going,
You light it, well, you've lit in fireworks, right?
Yeah.
That's what it is. The solid fuel rocket is fireworks. Yeah.
Why did they change it from Cape Canaveral to Cape?
Well, here's what happened. When John F. Kennedy authorized the program, they said, hey, we got to name this place after John F. Kennedy. So they called it Kennedy Space Center. And then they said, oh, well, it's right there on Cape Canaveral. Well, we better change that to Cape Kennedy, too. So that's what they did. But that wore off after a while. And the people around it who live in that neighborhood, they kind of thought that, hey, let's get back to the way it was. This is Cape Canaveral. It's always been that way. So they changed it back. So it's now Cape Canaveral, but we have still have the Kennedy Space Center there. So that's the place to visit. Got anything else? I think we're done.
Thank you.
You bet. I enjoyed it. By the way, this is a copy of the real countdown as it was issued. You know, so. That's what we work from. Huh?
All the stuff they went through?
Well, yeah, this one, I'm missing one of the steps in here, but it's